Okay. So this one, given r theta, you want to convert it to x and y. So mean you want to find x, right? Okay. So as just now, as I said, you just need to draw the diagram. Okay, this is y, this is x, this is r. So this point is x, y. Theta is measured anti-clockwise from positive x. And then from, you're calling cos theta, x divide r. So x is r cos theta. Okay, finding sin theta is y over r. So y is r sin theta. Okay, that's why x is r cos theta. Okay, put up r is 6 and then cos pi over 6. Okay, you may press using calculator, or you can use a special angle. As I said, this is pi over 6 is 30. You have, as we know, sin pi over 6 is half. Okay, this is as in my secondary school teacher teach me sin pi. You just remember this one, sin pi over 6. This is actually 30 degree is half. Okay, so what you need to do, if this one, if let's say this is pi over 6, 30, this will be pi over 3, 60 degree. Sin over 6 divided by hypotenuse. And then this will be sec 3. So cos will be here, sec 3 divided by 2. That's why I have 6 sec 3 divided by 2. The answer is 3 sec 3. So y is r sin theta. Okay, r is 6, and then sin pi over 6. Sin pi over 6 is 1 over 2. That's why you have 3. Okay, or you may use a scientific calculator. I hope my calculator still works. So, okay, make sure you're in radian mode. Make sure you're in radian mode. So you want 6 cos pi three sec 3. Provided, okay, if you want the answer, okay, in term 3 sec 3, provided you have the Casio ES mod onward, and this is the latest model, where you can plot the graph, okay, by scanning the QR code. You see the QR here? And then if you want, okay, the y, this is sin. Check the sin. So 3. So is it okay? This is polar to Cartesian. Polar to Cartesian. If you want Cartesian to polar, for example, we pick up question 2. Okay, let's say question 2a, given a point is given in rectangular coordinate. Find 2 pair of polar coordinate for the point, 1 pair satisfying r positive, theta from 0 to 2 pi, and the second pair satisfying r is positive. Okay, mean the second pair, you want you to measure the theta. This one is theta positive, this one measured theta negative. So mean one you measured theta positive is anti-clockwise, theta negative is clockwise. Okay, for example, we take question 2a, negative 5, 0. You want to change it to r theta. is it? Not good. Put it here. Now it's negative phi 0. Mean xy want to change to r theta. Okay. And then again from the same diagram, you know, okay, r here, using Pythagoras theorem, r squared is x squared plus y squared. You have here r squared is x squared plus y squared. Taking tangent theta will be y over x. Okay, so theta will be arctan y over x. Okay, so you want to find r. Okay, r will be square root x squared plus y squared. Okay, will be negative phi squared plus 0 squared, where you have phi. Okay, this is r. Okay, theta will be arctan y divided by x. Okay, y 0. Okay, so it's 0. Okay, you can see, check the solution. This is x, this is y. Let's say this is negative, x is negative phi, y is 0. So if you solve using formula, you see angle is 0, but you have to check with the point that the location. Okay, negative phi 0 is actually at the second quadrant. So the answer, okay, the theta here should be, if we measure, okay, anti-clockwise should be pi. If we measure, okay, clockwise, theta is negative pi. So the answer you have actually phi pi, okay, or phi negative pi. Okay, and actually in your calculator, you can actually, you see, I want to see, you see here, this one convert to rectangle, this one convert to polar. Okay, clear first. Okay, this is polar, so mean given coordinate should be, let's say, negative phi, comma, how to press comma is here, shift here, 0. They give you r is 5, theta is 3.14, which is pi. I mean, using a scientific calculator, you may find yourself. Okay, POL here. This is polar, changing to polar coordinate. So mean polar coordinate, so you need to key in the xy coordinate here. They give you, okay, r5, this is a theta. Okay, or question 1a just now, given the polar coordinate, you want to change to, okay, rectangular. So the REC, the yellow color, you need to press the shift. So I clear first, shift here. So you want to convert to rectangular, okay, coordinate. So R is 6, comma is here on top of the right parenthesis. Shift here. Pi over 6, pi divide 6. You close it. So x, they give, okay, this one you won't get the 3 sub 3. So y is 3 correct. So you can check back 3 sub 3, 5.11961. Then 3 sub 3. Yeah, 5.1962, because this one I fixed to 4 decimal place. So any questions here? Okay, we have shown, okay, each one example, and here we'll pick up one question from tutorial to solve it, and we'll show you, okay, manually and also with the help of your calculator using the polar, okay, POL and the REC, where you can directly get the answer for you to double check whether your manual solution is correct or not. Okay, any question? Hadi. Muhammad Hadi,
Yes, Doctor.
any questions?
So far, no, Doctor.
Okay, thank you.
Doktor,
Yes.
yang untuk yang macam doktor tekan kalkulator emulator ni kan, macam mana doktor tekan yang rectangular dengan apa tadi lagi satu tadi pola
Pola, POL tu pola.
macam mana doktor tekan tadi?
You cari you punya calculator yang ada POL REC, bergantung model calculator dia mesti ada. Yang yellow color.
Okey, bawah tu. Okey.
Yellow color, kalau katakan nak tekan pola kan?
Shift dulu
Shift. Ini.
Okey.
So pola maksudnya masukkan XY lah. Katakan masuk yang contoh example 3, nak comma yang atas ni. Yellow shift. 34 sepatut A dapat 5. A5. Ni theta dia.
Okey, doktor.
Kalau nak rectangle, shift ni. Rectangle katakan A dia set 2. Ni katakan set 2 pi per 4 lah. So X1, Y1. Okay. This one okay. So this one for you to double check your answer, but you still need to show the step. Especially the formula. Formula is okay, basically this chapter formula is not given. We want you to derive the formula. But you can use this one to double check whether your answer is correct. Okay. If no more, we'll look back the 3D coordinate system where you got cylindrical, spherical. Okay, and then tab. Okay.
To become R theta Z. So it's actually 3D polar coordinate where Z maintain its value. So here,
mean the polar coordinate in 3D becomes cylindrical. Okay, polar like you let's say you have only circle. When you have a 3D circle, it becomes cylinder.
To raise up the polar coordinate to 3 space, it becomes cylindrical coordinate. Okay, it's spherical.
Spherical, you have the sphere.
Like this. Spherical, normally you deal with the spherical surface. If cylindrical will be normally cylindrical surface. So spherical surface, so mean actually you have a x, y, z. In Cartesian coordinate, you got x, y, z. To change it to spherical, it's actually from this x, y, z, you draw straight line up to the origin, but now it's in 3D space. So this point, okay, from the x, y, z to the origin, okay, this radius is actually radius of a sphere, or we call it, we put it in rho, because R we use for polar coordinate, so it's spherical.